So here on this slide, on the left I have warm air, represented by red spheres, and on the right side of the slide I have cool air, represented by the blue spheres. Now they're in the same cube that we saw in the last lesson, but the cube is just there to give you a constant volume, a constant space. Both sides are equal in the amount of space that the air is occupying. Now in our last lesson on just general density, we learned that the amount of molecules in a particular given space determines whether something is more dense or less dense. So we learned that if it had more stuff in a given space, it was more dense, or if it had less stuff in a given space, it was less dense. And that same principle applies here to warm air and cool air. On the left side here, you can see that warm air is less dense because it has less molecules in the same amount of space that cool air does. So as you can see, we have 6 molecules of warm air here. Now, if you look over to the right side of the screen, you'll notice that we have many more molecules. We actually have 20 molecules in this cube here. So as a result, cool air is going to be more dense because it has more molecules in a given space. Now that's the basics as to why warm air and cool air have different densities, but let's take a look as to what actually goes on to make warm air less dense and cool air more dense. Alright, so as we're looking at our cubes of air here, you'll notice again that the warm air has much fewer molecules in it than cool air does. And the reason why has to do with the speed of the molecules. Warm air molecules move faster than cool air molecules. So since warm air is moving faster, there are going to be fewer of them in a given space, as opposed to cool air where they're moving much more slowly, so you can pack more of them in a given space. Now the speed of the air molecules is what makes warm air feel the way it does. So when we take the temperature of something, what we're actually doing is we're taking a reading on how fast the molecules are moving. So since warm air molecules are moving at high speeds, they're going to have high kinetic energy, which means they're fast. And as a result, they're going to register high temperatures. Whereas the cool air molecules are moving at much lower speeds, so they're not going to really have as much energy because they're not moving very much. And that low kinetic energy, or energy of motion, is going to register low temperatures on a thermometer. Now, one way you can kind of remember this is think about how you are when you go to gym. If you're moving around at high speeds and moving around a lot, and you're running and you're sprinting and you're moving fast, you're going to increase in temperature. So just remember that idea of fast motion increases temperature or leads to an increase in temperature. Now, if you were too hot in gym, what you would do is you would stop and you would rest. And when you're stopping, you're not moving very fast if you're moving at all, so you're going to have a much lower speed or low kinetic energy, and as a result, your body will cool down, and then you'll start to feel cooler because right now your body will then be registering a lower temperature. Warm air is less dense because they move fast, and as a result, there's fewer of them in an area. And because of their fast speeds, they're going to register high temperatures, which is what makes them warm. Cool air is the opposite. Cool air moves slowly, so there are more of them in a given area, and because they move slowly, they have low kinetic energy and they have lower temperatures. The last thing I want to talk about really quick is the idea of heat. Since the molecules in the summertime are moving very fast and there's more of them moving very fast, you're going to have really big collisions between the molecules. So as they move fast and collide into each other, they're going to release a lot of heat. So they gain a lot of speed because, as you notice, there's a lot of space in between the molecules, and because there's a lot of space, they can fly really fast, bump into a molecule that's just moving in the same direction randomly, and as a result, this big collision is going to release a lot of heat into the air. So in the summertime when you're feeling hot, it's because these air molecules are slamming at high speeds into your skin and releasing this heat onto your skin, making you feel super hot in the summertime. However, in the wintertime, what happens is that these molecules move much more slowly. So because they are low speed moving molecules, they're going to have smaller collisions and release low amounts of heat. So this air molecule here is going to move nice and slow and collide with that air molecule, and as a result, because there's not a lot of room to gain a whole lot of momentum, when they collide, they release very little heat. So in the wintertime, when it's cold outside, these air molecules that have been around you all year long, they're just moving slower. And as they collide into your skin, they don't release as much heat, which is why you feel cold.